Hi everyone, I'm Dr.D.Princy, Assistant Professor, Department of Computer Science with Cyber Security, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this video, I'm going to explain the different types of digital signature schemes, mainly RSA and DSA. In my previous video, we have seen about digital signature, components, and the types of digital signature schemes. First, we have to see about RSA. RSA algorithm, it is a public cryptographic mechanism used to generate the digital signature. Mainly, it is used for encryption, used as an encryption algorithm, and also it is used as the digital signature algorithms. The steps to generate RSA keys. First, we have to choose two prime numbers P and Q. Next, we have to compute n. N is nothing but the product of P and Q. Next, we have to compute totient, which determines the equalist totient function, totient of n. Next, choose E. E is an integer that is co-prime with totient of n. Next, we have to compute D. D is nothing but the modular multiplicative inverse of E modulo totient n. The final steps is form keys. By the previous computation, we have to generate or create the public key n comma E and the private key n comma D. So E is the public key and D is the private key. After creating the pair of two keys, we have to generate a digital signature. To generate a digital signature, we have to follow two steps. One is apply a cryptography hash function to the message. The second step is compute the signature, which is the calculation of the signature using the hashed value and the private key. For generating, we can use the private key in all digital signature schemes. For verification only, we can apply the public keys. Verification process. Compute H. H means hash value. So calculate the hash value of H dash using S, E and N. E is the public key. And verify H dash equal to H of M. If it is equal, the message is original. Next, signature validity. Confirms the signature's validity if the values matches. H equal to H dash. Signature invalid. Suppose if the value does not match with the previous hash value, which indicates the signature invalidity if the values differs. The next digital signature scheme is DSA, digital signature algorithms. It is the core algorithm for the digital signature. Why it is a core means this is the standardized algorithm for governments and the transaction process. It includes modular arithmetic, that is a mathematical foundation of the DSA, and it also applies discrete algorithms. This is the key cryptographic principles in DSA. Next, FIPS standard, which is official recognition and use of DSA. For those purpose, this is recommended by the governments. The steps to generate keys in DSA. First, we have to choose prime Q, prime number of a specified bit length. Next, we have to choose a prime P. P, there is a criteria that means Q divides the P minus 1. Next, we have to choose an integer G. G within the range 1 less than G and less than P. And G power Q modulus P equal to 1. Based on this condition, we have to choose integer G. Next, choose random X. This is a random integer number such that 1 less than or equal to X less than or equal to Q. the x value between the 1 and q. Next, based on the four values p, q, g and x, we have to compute y. So y is equal to g power x modulus p. Next, we have to generate the public and private keys. Public key is p, q, g, y and the private key is x. See, after generating the key, we have to generate the signature. For generating the signature in DSA, we have to compute R. R is equal to G power K mod P and mod Q. Compute S. S is equal to K inverse H power H of M, that is hash value, plus X into R mod Q. After computing R and S, we have to verify the values, that is check for zero values. After that, we have to form the signature and add it with the message. Next, signature verification process. Compute the W. W is nothing but the modular inverse of S. Compute U1, that is intermediate first value. The second intermediate value is U2. So after that, we have to compute V. So V is the verification values. Then we have to check with V equals to R. If both are equal, it determines the validity. If it is differs, the signatures are invalid. These are the process of RSA and DSA. Thank you all.